Have another great calculation question for you. This time it's relating to transformers. So the question reads, a transformer has 50 turns on the primary side. Turns means the number of loops, if you will, and 250 turns or number of loops on its secondary side. So it's the primary winding and the secondary winding, each having a different number of loops. And the question is asking, what's the secondary voltage? Can you calculate that if you know the primary voltage is 24 volts AC? So there's only a few equations you need to memorize to understand the relationship between volts, current or amps, and the number of turns or loops on the primary and secondary winding of a transformer. And they're shown down here on my bottom right. Let's take a look more closely. So if you take a look at our image here, we have a graphic of a transformer, and EP indicates that there is some voltage on the primary winding, and ES means there is some voltage on the secondary winding. Now, normally voltage is indicated with the letter V, but it's not unusual to see the letter E because E stands for EMF, which is measured in volts. Okay, so we've got primary voltage, secondary voltage. Okay, we're feeding current to the primary winding. It's doing the job as usual of creating a magnetic field, which induces voltage in the secondary winding. And if the secondary winding becomes a secondary power source for volts, it can be used for a secondary circuit as drawn here. And because I have some type of load connected to the secondary circuit, current's going to flow through it like this. Okay, so the relationship between the volts in the primary winding, the volts in the secondary winding, and the current flowing into the secondary winding with the current flowing out of the secondary winding is going to be right here. We got primary volts divided by secondary volts is equal to secondary current divided by primary current. And each of those things is also equal to the number of loops or turns in the primary winding divided by the number of loops or turns in the secondary winding. Now, in our question, we are given the number of turns on the primary and secondary winding, and we're given secondary voltage. So what we're really interested in looking at is how do we relate volts to number of turns? Well, we could say VP divided by VS is equal to NP divided by NS. And that is indeed what we're going to do to complete our calculation. So let's write that over here. VP divided by VS is equal to NP divided by NS. And let's plug in our numbers now. So we want to know the secondary voltage. We are given the primary voltage. So 24 volts divided by the secondary voltage is going to be equal to the number of turns on the primary is going to be 50 divided by the number of turns on the secondary is 250. Now, to solve for VS, we're going to perform your basic cross multiplication. And cross multiplication means that VS times 50 is going to be equal to 250 times 24. So I'm going to rewrite that. Oh, I guess we can go up here and write that. Our cross multiplication, basic algebra. 24 times 250 is going to be equal to VS times 50. All right. And then if we divide both sides by 50, we can cancel the 50s over here. And of course, now we're going to solve for VS. So the final calculation is that the secondary voltage, which is what we're looking for, is equal to 24 times 250 divided by 50. And your answer should calculate out to C, 120 volts.